Okay, so today we're going to be talking about how to solve for independent probability. So using independent events, we're going to determine what is the probability using independent events. So first thing we are going to do is we're going to review how to multiply fractions, because when we are finding independent probability and when we're finding dependent probability, we're going to be multiplying fractions, and that's how we're going to find the probability. So first we need to quickly review how to multiply fractions. So whenever you have two fractions, when you're multiplying them together, we are going to multiply top times top, bottom times bottom. And remember, always simplify. So we've got 1/2 and 3/4. So top times top, so 1 times 3 is 3, 2 times 4 is 8. So top times top, bottom times bottom, create your new fraction, and then always simplify at the end if you can. So 3/8 cannot be simplified, so that's our answer there. All right, we've got 1/8 and 4/8, so let's multiply. 1 times 4 is 4. 8 times 8 is 64. So this is a fraction that can be simplified. If you want to, always start by simplifying by 2. That's probably the easiest to identify. So we can go ahead and do that. If we simplify by 2, that means divide by 2 on the top, divide by 2 on the bottom. Or if you recognize that those two numbers can be simplified by something bigger, go for it. But we can start with 2. So 4 divided by 2 is 2. 64 divided by 2 is 32. And then again, you can simplify by 2 to make it easy on ourselves, because that's not the simplest version. 2 divided by 2 is 1. 32 divided by 2 is 16. So 1/16 is our simplified fraction. Okay, one more. 4/6 and 3/5. So 4 times 3 is 12. 6 times 5 is 30. Okay, so this one I'm going to jump straight to, instead of dividing by 2, I'm going to jump straight to our simplified version. So we can simplify the top and the bottom by 6 to get us there faster. 12 divided by 6 is 2. 30 divided by 6 is 5. And then that is as far as our fraction will go. So 2/5. So that's just a quick review so that we can know exactly how to multiply fractions in our problems down below here. So when an outcome of an event does not, we already talked about this, independent probability is when the outcome of an event does not impact the outcome of a second event. If one does not affect the other, those are called independent events. So that's what we talked about in the first video. Remember, we talked about if I roll a dice and I flip a coin. Those do not affect each other's outcomes. One getting a heads on a coin and rolling a 4 on a dice. Those do not have anything to, those do not affect each other. So those are called independent events. So when we are solving for independent probability, like we said, we're going to be multiplying fractions. So we're talking about 2 things or 3 things or 4 things that are happening. So if we go back to the example of rolling a dice and flipping a coin. So these are 2 events that are happening. I'm going to roll the dice and I'm going to flip the coin. Those are 2 events that are happening. So I'm going to have the probability of rolling, let's say the probability of rolling a 2 on a dice, and let's say maybe finding the probability of flipping tails on a coin. I'm going to have the probabilities that I'm going to be multiplying together. Probability is a fraction, so I'm going to be having those 2 fractions multiplied together. So if I was to roll the dice and flip the coin, I can find the probability of, let's say, like I said, rolling a 2 on the dice and flipping tails on the coin. I would find those 2 probabilities and multiply them together, and that would give us our independent probability. So what we're going to be doing is we're going to be using the fraction for the probability of the first event, and then the fraction of the probability of the second event. So we're just multiplying 2 fractions together. So let's go ahead and take a look at what that means in a real life example. So in a board game, students draw a card replace it, and then draws a second card. So remember, that's important. The word replaces it is important because that means we're putting it back. It's an independent event. By drawing a card and putting it back, that doesn't affect the probability of getting any of the other cards. Determine the probability of each event. So 1, to earn 50 points, a student must draw a heart-eyed card and then an angel card. So we're going to have 2 probabilities, the probability of drawing a heart-eyed card and the probability of drawing an angel card, and we're going to be multiplying those together. So let's look at our cards here. There are 1, 2, 3, 4, 5, 6, 7, 8 cards total, and there are, let's see, 2 cards that have heart eyes. So to find the probability of drawing a heart-eyed card, that's going to be 2 out of the total 8. 2 over 8 would be the probability of drawing a heart-eyed card. So that's where we start. Just find the probability of the first event, drawing a heart-eyed card. Okay? Then let's look at what is the probability of drawing an angel card. So look for, okay, here's an angel card. There's only 1. 1 out of 8 total is going to be our probability of drawing an angel card. So once you have your 2 probabilities, then we're going to go ahead and multiply them together. Okay, so this is where we do top times top, bottom times bottom, and reduce. So 2 times 1 is 2. 8 times 8 is 64. Okay, can that be reduced? Yes, by 2. 2 divided by 2 is 1. 64 divided by 2 is 32. So that is our answer. That is the probability of first drawing a heart-eyed card and then drawing an angel card. Awesome. Okay, number 2. To earn 20 points, a student must draw a sleeping card and then an angry card. So again, find the 2 probabilities. And then we multiply them. So sleeping, let's see, 1, 2 sleeping cards, 2 out of 8 total. Okay, and then an angry card, 1, 2. So 2 out of 8 are angry cards. So here we go again, multiply top times top, bottom times bottom. So 2 times 2 is 4, 8 times 8 is 64. So this is the same fraction we simplified up here. So we can just go ahead and write 1 over 16 because we already simplified that one together above. Okay, number 3. To earn 10 points, a student must draw an angry card or a laughing card. So first it's going to be probability of angry or laughing, then an angel card. So looking here, so this has 2 things that we're going to be looking for. We're going to look for an angry card or a laughing card, and we're going to put that together in one fraction. So angry, laughing, angry. So 1, 2, 3 out of 8. There are 3 out of 8 cards that are angry or laughing. And then there's only 1 angel card, so 1 over 8. And that's what we're going to be multiplying together. So 3 times 1 is 3, 8 times 8 is 64. And can that be simplified any further? No, it cannot. So that is our answer. Okay, hopefully as we do more and more and more, we get the hang of it. We're just going to do a couple of these practice problems together just so you get the idea a little bit better. So let's look at this one right here. Kylie has a coin and a number cube. Whenever you see number cube, that also means dice. So she has a coin and a dice. She flips the coin once and rolls the dice once. What is the probability that the coin lands tails up and the number cube lands on a 4 and the dice lands on a 4? So again, 2 things are happening. We are rolling the dice, flipping a coin. So first, it says, what is the probability that the coin lands tails up? Okay, so we need to find the probability of getting tails on a coin first. So there's only 1 outcome out of 2 outcomes. There's only 2 outcomes on a coin. 1 out of 2 on a coin, one of them is tails. That is the probability of getting tails. And then we're going to be multiplying by the probability that the dice lands on a 4. Okay, so there's only 1 outcome that is a 4. Only 1 outcome that is a 4 out of 6 total outcomes on a dice. So 1 out of 6. that is the probability of rolling a 4. Now, it's not going to be 4 over 6 because we just want to know how many outcomes are there that are the number 4. There's only one outcome of rolling a 4 on a dice, so there's 1 over 6 is the probability of rolling a 4. So those are the two fractions that we're going to be multiplying together. So top times top, bottom times bottom. So 1 times 1 is 1. 6 times 2 is 12. And that cannot be simplified any further. So that is our answer. Okay, let's go to this one. There are 6 marbles in a bag. 3 are green and 3 are yellow. So half and half. 6 total, 3 are green, 3 are yellow. If you draw a marble, replace it, or that's important, replace it, so that's independent, like what we've been doing. If you draw a marble, replace it, and then draw another, what is the probability of choosing 2 yellow marbles? Okay, so we're going to have to imagine this because I do not have green and yellow marbles, but if we imagine this, think of your jar with green and yellow marbles, okay? There's 6 total. Let's first find the probability of drawing a yellow, okay? So there's 3 yellow marbles. It says there's 3 yellow out of 6 total, so you've got your jar. The probability of drawing 1 yellow is 3 out of 6. Okay, so that's our first fraction. They say we put the yellow marble back, so now everything is the same. 3 green, 3 yellow. Everything is the same. So now, again, what is the probability of getting a yellow marble the second time? So then if I go in, draw a yellow marble, there's 3 out of 6 outcomes still to get a yellow marble. Because I put it back, that didn't affect anything. So there's still 3 yellow marbles out of 6. So if we go ahead and multiply those together, 3 times 3 is 9. 6 times 6 is 36. Okay, that I can simplify down by 9 to give me 1 over 4. So that is our final answer. Okay, we're going to do 2 more. What is the probability of flipping 3 heads in a row? Okay, so before, in these 2 examples and on the other page, we only had 2 events that were happening. Rolling a dice and flipping a coin. Picking out a yellow marble and then picking out a yellow marble. This question says, what is the probability of flipping 3 heads in a row? So that's like what we would be looking at if we were to flip a coin once, flip a coin a second time, flip a coin a third time. So we have 3 events that are going to be happening. So that means we're going to have 3 fractions that we're going to be multiplying together. If we have 3 events, you have 3 fractions. If you have 2 events, you have 2 fractions. So you have to look very carefully at what the wording is. This says probability of flipping 3 heads in a row. We're going to have 3 fractions here. So thinking about a coin, what is the probability of getting a heads? Well, there's only one option on a coin that is heads out of 2 total outcomes. So that is the probability of getting a heads when I flip it the first time. Okay, when I get ready to flip the coin a second time, again, what's the probability of getting heads? 1 over 2. So that's flipping a coin a second time. And we're going to flip a coin a third time. So what is the probability of getting heads? Again, 1 over 2. So I have 3 events, 3 fractions, same thing, top times top times top now, bottom times bottom times bottom. So 1 times 1 is 1, 1 times 1, again, is 1. So 1 on the top. Now let's go 1 by 1 here. 2 times 2 is 4, 4 times 2 is 8. So there should be an 8 on the bottom. So the probability of flipping 3 heads in a row when you're flipping 3 coins would be 1 over 8. All right, we're going to do 1 more and then we'll be done. So last one, this one with the candles. Mackenzie chooses 1 candle, returns it to the bunch. So there we go again. There's independent probability like we've been doing. She puts it back so it doesn't affect the probability of getting anything else. She returns it to the bunch and then chooses another candle. What is the probability Mackenzie selects a polka dot candle both times? So looking at the candles, what is the probability that she gets a polka dot candle the first time? So we've only got 2 polka dot candles out of 1, 2, 3, 4, 5 total options. So the probability first of getting a polka dot candle is 2 over 5. So she's only picking 2 candles, so that's why we're only going to have 2 fractions here. If she takes the polka dot candle, she puts it back, then she has all these same options when she picks a candle a second time. Again, what is the probability of getting another polka dot candle? It would be 2 polka dot candles out of 5 again. And multiply. So 2 times 2 is 4. 5 times 5 is 25. And that cannot be simplified any further. So that's our final answer.